All right, so this is a continuation of what we did yesterday. Yesterday we solved by elimination. Today we're going to solve by substitution. So it's similar to what we did with two equations. We're going to isolate one variable. But instead of just plugging it into one other equation, we substitute it into the other two equations. Thank you. Okay. Isolate one variable and substitute into the other two equations. All right, so basically I already have a couple of them that are kind of alone. I'm going to choose to isolate the z in that first equation, but I could isolate the y in that equation, or I could isolate the x down in the bottom one, but I just chose to do z. So if I isolate the z, I end up getting that z is equal to 2x minus y minus 15. Basically, I just added the z to both sides and then subtracted the 15. So now I have to take that expression, that 2x minus y minus 15, and I'm going to put it in place of these other two z's. So solving by substitution with a 3x3 system can be a little bit cumbersome. Personally, I think elimination is usually easier, but there may be times when substitution is easier if I've already got something isolated. All right, so for the second equation, I had 4x plus 5y plus 2z. So now I'm going to do 2 times the 2x minus y minus 15, and that equals 10. So 4x plus 5y, distribute my 2, and I get 4x minus 2y minus 30 equals 10. So if I combine my like terms, 4x and 4x gives me 8x. 5y minus 2y gives me a positive 3y. And then if I add the 30 to the other side, I get that it equals 40. So 8x plus 3y equals 40. Now I'm down to just x and y. Now I have to do the same thing with the other, the last equation. I've got negative x minus 4y plus 3z, so I write 3 times the 2x minus y minus 15, and that equals negative 20. All right, let's see here, where was I? So negative x minus 4y plus 6x minus 3y minus 45 equals negative 20. So negative x plus 6x gives me 5x. And negative 4y minus 3y gives me minus 7y. And if I add the 45, that equals 25. Okay, so at this point, it's actually really not clean to use substitution anymore because I'm going to end up with fractions no matter how I do it. So at this point, I'm going to choose to switch over to elimination, and there's no reason you can't do that. You can mix the two together if you want to. I mean, I could solve one of those for y, but then, like I said, you end up with a bunch of fractions, and it's just ugly. So I know you guys like to avoid fractions if you can, right? All right, so what I'm going to do is I'm going to multiply this equation by 7, and I'm going to multiply this equation by 3 so that my y's will drop out. And so I get 56x plus 21y equals 280. And then for the other one, 3 times 5, I get 15x minus 21y equals 75. So when I add those together, my y's cancel out. 56 and 15, I get 71x equals 355. And believe it or not, that means x is equal to 5. 71 goes into that 5 times. All right, so now I can take what I just found for x, and I can go and substitute it into either one of the other ones. I'll just put it into this one. Why not? Okay, so if I plug it in there, I have 5 times 5 minus 7y equals 25. So 25 minus 7y equals 25. When I subtract the 25 from both sides, I get that 7y is 0. So what does y have to be? Y has to be 0. All right, so now that I have x and y, I can go back to any one of the original equations, or actually what I'll go back to is I'm going to go back to my where I had z solved out, that z was equal to 2x minus y minus 15. So z is equal to 2 times x minus y minus 15. That's 10 minus 15. So z is equal to negative 5. Okay, so then if I go back and I test it in each of the original equations, that's what these are doing down here so I can see them. All right, so I'll test it in all the equations then. So 2x, so 2 times 5 minus y minus z equals 15. I get 10 plus 5 equals 15. That one works. If I test the next one, 4 times 5 plus 5 times 0 plus 2z, so negative 5 equals 10. I get 20 minus 10 equals 10. Is that true? Yes, it is. And then finally testing it in the last one, negative x is negative 5 minus 4y, so 4 times 0 plus 3 times negative 5 equals negative 20. So I have negative 5 minus 15 equals negative 20. That works too, so I know I did it correctly. My final answer is 5, 0, negative 5. Any questions there? These take a while. That's why I didn't give you a whole bunch of them for homework. So yeah, substitution, it's up to you whether you want to use it. If it's one that makes sense to use it, go ahead. If you get partway through and it makes more sense to switch to elimination, you can do that too. But in general, I think elimination is probably going to work better for you guys. Use whichever method you prefer, or whichever method makes sense for a given problem. Okay? Any questions on that? All right, so the next thing we're going to talk about is graphing these equations. Sigh, moan. All right, so graphing in 3 variables. All right, so one of the things that's kind of funky that throws people off sometimes is where they have chosen to put the axes. They now have x essentially coming out of the paper at you, and y is over here, and the z is the one going up. So that's different than what you're used to in terms of your organization of the axes. So, so your positive x is where the x that I highlighted, your negative x is on the opposite end, and then your negative y would be over here, and your negative z is down here. Yeah, it's like you're looking at a 3D graph from above, exactly. So it is a little bit different. It is a little bit difficult to visualize this, and I understand that. I want to kind of show you sort of as best I can. I've got some index cards that I've put together here. So what you have is you've got x coming out of the paper towards you, right? And you've got z going straight up, and then y is going side to side. So so yeah, we're used to just having the x and the y and no z, but so it ends up having 3 dimensions. So you remember how we had quadrants with our when we had just x and y? When I just have x and y, this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. You guys remember that? Okay. Well, when z is positive, it's still the same quadrants. Only now they're not quadrants because there's 8 of them. So it's called an octant. Write that word. There are 8 octants. And so when z is positive, when everything's positive, that's still your first octant. And then as you go around, it's 1, 2, 3, 4, just like it was before. And then when z is negative, that gives you the 5, 6, 7, 8. So if z is negative, it's 5, 6, 7, and 8. So the green ones are when z is negative. And the blue ones are when z is positive. Okay, so you can use that to figure out what octant something is in. I don't think any of the problems tonight are going to ask you to do that, but I just want to make sure I explain that to you. Okay? Alrighty. So we're going to graph 3x plus 4y plus 6z is equal to 12. And it's actually not as bad as it seems. All we're going to do is find the intercepts. So remember on our warm-ups how we found the x and y intercepts for lines? It's going to be very similar to that. We're going to do, but now we have 3, right? So I'm going to find x when both y and z are 0. I'm going to find y when x and z are 0. And I'm going to find z when x and y are 0. So if y and z are both 0, what's x going to have to be? 3x equals 12, so x has to be 4. Okay? Then I plug in a 0 for x and z. And so what does y have to be? A positive 3. And then finally, I will plug in 0 for x and y. 6z equals 12, so z is equal to 2. And then you just plot those on the axes. So on the x-axis, I go to 4. 1, 2, 3, 4. On the y-axis, I go to 3. 1, 2, 3. And on the z, I go to 2. 1, 2. And then you just connect the points, because what this equation actually represents is a plane in space. So that's the plane that you're representing with that equation. So was that so bad? Yes. Question?
Would the plane keep going?
Yes.
Just in between those points?
No, the plane is infinite. We're just assuming that that's the only part we could see or whatever. Because there's no way to draw an infinite plane. But yeah, the plane is infinite. It would be continuing infinitely off of all those sides. And it's just at that angle. Okay? So I want you guys to try graphing that one. You can do it in your notes, or if you prefer to use the whiteboards, you can. You could just add the extra axis onto your whiteboards if you'd rather do that. All right, do we agree on the intercepts then? 3, 4, and -6? Okay. I still need to see a few more graphs, though. I've only seen a handful. Okay, so yeah, the x-axis, remember, it's kind of coming out of the paper towards you, so positive x is coming towards you. 1, 2, so you should have had it at 3 on your x-axis, positive 4 on your y-axis, and then -6 on the z. 1, 2, 3, 4, 5, down here. Okay, so your graph would have looked something like that, hopefully. Okay? Any questions?
Wait, so the x, is it up?
X is this axis right here.
Yeah, so like going towards you would be positive?
That's positive, yes. Going towards you is positive. This is your positive x. Your negative x would be going away from you.
And then the y is still positive.
Okay, y on the right side is positive, negative y on that side, and then negative z down here. Okay?
Is there a way that you can show us in like 3 dimensions without on like not on a big piece of paper?
I'll have to think about that one. If I can come up with a model to show you in real life.
Yeah.
Okay. Okay. I'll see what I can do. All right, so that's it for the lesson.